Previously, we've used factorizing and completing the square to solve quadratic equations, as finding the roots here. This method is the third method, apart from I guess using the calculator, that you'll need to know. It's a very, very important, very, very fundamental algebra. That is the quadratic equation here. Now, don't let that intimidate you. This is given to you. In fact, this is cut and pasted from your exam paper. Give it to you. If you can understand how to use this, you'll find the exam pretty easy. Well, the questions to do with quadratic equation anyway. So what does it mean? Well, we can have a quadratic equation written in this form. If we set it equal to 0, if we solve for x, we would be finding the roots here. So this is one of the roots there, one of the roots there. It's where they cross the x-axis, the x-intercept. Okay. The a, b, and c in this equation here and this equation here are the same a, b, and c as up there. So this equation here is the equation y equals x squared plus 6x plus 5. And it's one that we did previously. It's pretty easy to factorize. It's pretty easy to complete the square using that one. So when would we use that? Well, we can use it all the time. In fact, your calculator uses this method to solve polynomial, well, quadratic equations. What does this bit mean? Well, it has a meaning as well. In fact, there's a lot of information that we can get from these equations apart from just the root. Okay, here are some other things we can use quadratic equation for. The c here is of course going to be y-intercept. Right, so this one here, the c at the end of it is 5, so if we here a is 1, b is going to be 6, c is going to be 5. So it's going to cross the y-axis here at 5. Alright. When we put in a, b, and c into this equation, we can find the roots. But we can also find the turning point using this as well. So the turning point, the x part of the turning point is given by this bit here. Way to remember it. So they give you this bit here, you'll see is the same as this bit here. The x part of the turning point, that is this part here, is going to be equal to minus b over 2a. So in other words, for this one here, minus b over 2a would be negative 6 over 2 times 1, which is 2, which is negative 3. And if we have a look, yep, sure enough, negative 3 is where we have the turning point. And if we put negative 3 into the original equation, we're going to find out what the y value for that turning point is going to be. So far, so good. What else can we see? The other thing that's really, really useful is seeing that if a is greater than 0, a is a positive number, it's going to look like this one here. If a is a negative number, it's a number that's less than 0, it's going to look like that. If a equals 0, it's not a parabola, it's a straight line. So whether a straight line is a special case of parabola as a moot point, we're going to say that it's not, and it's generally accepted that it's not. It's just a straight line. Unless it looks like this or like that, it's not a parabola. So far, so good. What about this bit here? What does that mean? This is the discriminant. And it's used for a few things, but for our purposes in level 2 NCEA, here's what it's used for. If b squared minus 4ac is greater than 0, there are two real roots. Right, so in this case, b squared minus 4ac must be greater than,
because there are two roots here. If b squared minus 4ac is less than 0, i.e. it's a negative number, there are no real roots. There are two roots, but they're two complex roots, but you don't need to worry about that until next year. What that means is that if that's the case, with b squared minus 4a is less than 0, the parabola never crosses the x-axis. Either it looks like that or it looks like that. And then you should be asking yourself, well, what if b squared minus 4ac equals 0? And it's a good question. What that means is there is, well, effectively one root. Okay. Actually, there's two roots in the same place, technically. What that means is that if we have our x-axis here and b squared minus 4ac equals 0, it's going to kind of come down and it's going to just touch it and then move back up again. So it has a root here, but it never crosses the x-axis, it just touches it. And if a is less than 0, it means it's going to come up here, just touch it and go back down again. Sometimes this is called an embrasse intercept, meaning it just comes up, and embrasse is French for kissing. So it's just going to come down, it's just going to kiss the x-axis and move back up again. Okay, let's have a look at some examples. Well, the example we've got here of what we can do with that. Okay, so our original function is y equals x squared plus 6x plus 5. We want to find, first of all, we want to find the roots. So to do that, we're going to work out whether there are two roots. We already know that there are two roots, but let's kind of prove it. Well, from this we know that a is 1 because there's a 1 in front of that x squared. B is going to be equal to 6 and c is going to be equal to 5. So we know straight away the y-intercept is at 5. Okay, let's find out the determinant. In this case, it's going to be 6 squared minus 4 times 1 times 5. 4 times 1 times 5 is 20. X squared is 36. So that's going to be 16. This is a number greater than 0, so two real roots. In other words, the parabola crosses the x-axis twice. Okay. The a here, 1 is greater than 0, so therefore it's going to look like that. So it's going to cross twice. Now the question is, where does it cross? Let's do that solving. Let's solve that using the quadratic equation. So it's going to cross it where x is equal to minus b plus minus square root b squared minus 4ac all over 2a. This bit here confuses students. It means we do it twice, once for adding, once for subtracting. Let's put in the numbers. One of the roots is going to be minus b plus the square root of b squared minus 4ac all over 2a. The other one is going to be at minus b minus the square root of b squared minus 4ac all over 2a. So in this case, we know that b squared minus 4ac equals 16. We worked it out just before. And we know that b is 6 and c is 5. Therefore, we know that minus b is going to be minus 6 plus the square root of 16, which is going to be 4, all over 2 times a, and 2 times 1 is 2. That's going to be minus 6 plus 4 over 2, and minus 6 minus 4 over 2. And this one is going to be minus 6 plus 4 is minus 2 over 2 is minus 1. And this one is going to be minus 6 minus 4 is minus 10 divided by 2 is minus 5. So in other words, it's going to cross the x-axis at -1 and -5. We already know that, really, because we can see it up here, -1 and -5. Okay, what's the turning point? Well, the turning point, we know the x value of the turning point, it's going to write it like that, is going to be minus b over 2a, and it's going to be at minus 6 over 2 times 1, which is 2. So that's at -3. And if we have a look at our original graph, yep, sure enough, it's at -3. So it's going to be a -3 something. So then we can put it into our original equation, which is going to be -3 squared plus 6 -3 plus 5. And I'll leave it to you to solve that. No, I won't. So it's going to be 9 plus, minus 18 plus 5. That's going to be -9 plus 5 is -4. So it's going to have a turning point at -3, -4. Is there anything else? Well, there is actually one thing that's not given to you, and that's why I'm shuffling paper. The sum of the roots. So root 1 plus root 2 is going to be equal to minus b over a. And the product of the roots, which is r1 times r2, is going to be equal to c over a. It's an a, not a 9. So the roots here, we know that one of the roots is at -5, the other one is at -4, is at -1. So that's going to be minus 6 over 1, which is -6. That makes sense. And c is 5, divided by 1 is 5. So there you go. Is there anything else we can do with it? Probably. But we'll need to do that in the next